Hey all, we're starting our very first live stream here, looking at some severe weather moving through the Fort Worth area this evening. We're starting this here at 9:33, and I'm just going to kind of go over the radar, and we're going to watch this as it happens. This live stream is completely unannounced, so we're not really starting off with any viewers. I wouldn't be surprised if some people join in a little bit later. We'll see how it goes. And this will give me a chance to kind of go back and review the quality, because my DSL here is not particularly fast. So looking at our radar here, we've got kind of an outflowish picture here. I can draw in the outflow boundary like this. So you can see that outflow just kind of surging ahead of the main storm. So yeah, right there. So outflow boundary pushing into the Fort Worth area. You can see it right there. Let me see if I can bring up the highways. Looking at GR level 2 here. I'm going to go to the GIS panel and pick out roads. There we go. Those roads are a little bit large. I'm kind of just experimenting and trying to get everything looking right. That way when we have a big tornado outbreak, I can get on here and everything will be already set. Let's see, settings for roads. I'm going to kind of dial that back a little bit. Interstate colors will knock down the background just a little bit. No, that's too thin. Yeah, I think just knocking out the borders is helping a lot here. Okay. In fact, let me change that just a little bit more. Roads, I'm going to make that 2. Okay. So now we can see a little bit more of the storms here. So right here, up here in the DFW Grapevine area, this is the first storm we had. We had a tornado warning on this about 30 minutes ago. In fact, that was all the way back here on 287 near, I guess that would be the U.S. Mint. There's a plant up there. No, not the Mint. That's not a coin plant. That's some sort of, I think that's where they actually print the actual bills. But that storm moved on off to the east like that, and you can see that wrapping appearance we have right here. So Meso is kind of buried in here. I'll zoom in here real quick. So DFW Airport is going to be in this area. Here's Grapevine. This is pretty close to Tim Marshall's house. He lives up in Flower Mound, so he's probably watching this if he's not out traveling. But let me pull up the storm relative velocity here. Now, you can see it's mostly showing outbound velocities here. I have not yet set up the storm motion on this. So to do that, I'm going to come up here to the top menu, trying to figure out where this is. Normally I use plain GS GR level 2, but I'm using Analyst for this one. So let me figure out where that's set. Yeah, I can't figure out where. Maybe is it the environment settings? No. What I'm trying to do is I'm trying to set the storm relative velocity storm motion, and that's not automatically extracted from the data, because this is level 2 data, so it doesn't have all that generated information. So we have to do that ourselves. Was that it? Just kind of skipped over that. No, that's not the one. So we're just kind of working out the bugs here. fact, while we're doing that, I'm going to pull up I'm just going to go back to live reflectivity there. You can kind of see what's going on. There's the base velocity. It's showing almost entirely outbound. We can't really see the important gradients in here. That's the reason I'm kind of going through this and trying to find the storm relative velocity. It is kind of hidden in there. In fact, I'm not going to really worry about that too much. Fortunately, we're seeing mostly just kind of outflowish patterns right here. Out ahead of this, you can see that right there. Outflow is pretty far ahead of this line by about 5 miles or so. So what's happening is we have the main cell stretching from around the Carsville area, around northwest Fort Worth on up to the Flower Mound area, and we're seeing the outflow just kind of surging ahead. So the main inflow is coming in from the south like that, and it's meeting up with the outflow coming in from the northwest. So the risk of severe weather is diminished quite a bit in the Fort Worth area. What we're mainly watching is this cell up here, which is tracking toward the, looks like Farmers Branch to Plano. I wouldn't be particularly too worried about the situation because this doesn't have a really good history of like tornadoes on the ground, spotter confirmed tornadoes, that kind of thing. Moving southwest down the line, this also looks kind of outflowish. One good measure that we can use to find out exactly where we home in on where the important storms are is going to be the VIL. That just gives us kind of a quick look at where the important cells are, because this is kind of like a cumulative, it's kind of like a sum of all the echoes up to the top of the storm. So that kind of nails down exactly what we're looking at for the areas we're interested in. So there's that cell right there near DFW. That's the big one. Got a couple here, but remember those are outflow dominant. And then the next ones down the line are what we're watching. This one here, northwest of Granbury. And then going on down to Stephenville and out into cattle country, not much. So let's take a look at that Granbury cell real quick. I'm going to switch over to the base reflectivity. And right now it's not showing anything particularly bad. One is the reflectivity gradient. You can see on the south side there's not a very strong gradient. It's very soft. So this is not it's not a cell we're particularly concerned about right at this minute. If we go higher up into the storm, see where the core is right there? In fact, let me set a place marker right there. If we go higher up into the storm, 4 degrees, 5 degrees of tilt, 6, you can see it's pretty much stacked vertically. What we would be looking for if this was like a severe storm is some overhang, like the upper level echoes would be off to the southeast or to the east. So right now it's stacked vertically. It's probably going to be okay for the next 15 minutes to 30 minutes at least. But of course we'll try keeping an eye on it. There's a little bit better reflectivity gradient along the leading side of this stuff in West Fort Worth. But again, it's mostly outflowish at this time. So the gust front is stretching from around Euless down to southern Fort Worth, on down to Benbrook, Lake Benbrook out in the area. Then let's circle back to the one that is near Louisville. So we'll zoom in right there. We've got a pretty good notch there, so that's somewhat of a HP-ish type structure. What does this look like as far as our upper level tilts? Okay, we're down at 0.5. Down to the bottom part of the window, let me stretch this back and Let me switch over to the broadcaster software so I can make sure you can see this. Yeah, there you go. You see down at the bottom, there's this readout right here. That tells us how high the cursor is above the ground, and I'm not sure if that's MSL. I can just set it right on the radar site. That's no, it's going to be AGL, so that's above ground level, above the radar site, the RDA there. So when we hit the storm that's in Flower Mound, we're up at about 2,100 feet above the ground. So this is just below cloud base level. So this gives us a good picture of what is underneath the storm, the lower parts of the meso. If we go up to the higher tilts, up to 3 to 4 to 5 degrees, we're getting up into the 15,000 foot level. This is the mid-level part of the storm where the meso is most strongly located. And then when we get up to 10 degrees, we're up at about 29,000 feet at this range. And then we finally hit the very top of the storm there at 44,000 feet, and looks like nothing above that. So let me set that storm top right there. I'm going to place the marker right there. So you guys are looking at live radar data here. This is 45 minutes past the hour here. The actual product time, the actual scan time was about 5 minutes ago there. So we go back downward through the storm there, and you can see in this case we've, in fact, let me go back here real quick. Scan time 43. We've got different scan times up here. I don't know if you can see that. I don't think you can. Yeah, there we go. That's one thing you have to watch out for when you're using the products. In this case, we have a mix of different times. This is 48 after the hour at the surface, and then we go aloft. We're at 43 minutes past the hour. So we have to be careful when we're looking at storm tilt and make sure that everything is consistent between all the levels. I don't have... Well, what I can do in this case, I can just run the surface, the low-level panel back. Okay, so there's 43. So here's the storm top. It's out a little bit ahead of the main part of the storm, so it's showing a little bit of tilt here with height. However, you can see that the outflow kind of extends, kind of pulls into the storm like that. So this is a good signature here for the potential for a severe cell. In fact, I got a text message. Text says a big storm approaching Garland. Yeah, that is true. And we are watching that. One thing that I like to do is, let me run this back up to the current scan, 48 after. One thing I like to do is look at the very least at consistency between the lower level products. Like if I'm looking for signatures here at 0.5, it's good to go up to 0.9 also. Because there might be a little bit of attenuation somewhere or something going on to where you see a slightly different picture at the slightly higher tilts, and that's what we're doing here. So that's a good thing to do right there. Now, as far as other products, what can we use here? How about spectrum width? That's a very underutilized tool there, and it's not on all the different radar sites on the internet. In fact, it's very hard to find. Spectrum width gives you an idea of the diversity of velocity signatures within one box, within one scan, I guess one sample, if you want to call it that. So if you have like a bunch of hail falling through a sample, and there's also drizzle and rain falling at a different velocity in there, you're going to get a higher diversity of velocity signatures, and that's going to show up as higher spectrum width. A big example of that is when you have a tornado moving through an area and you have like a dust cloud, you have sheet metal moving through maybe at 20 or 30 miles an hour, and then you have smaller pieces of lumber and nails moving at 100 miles an hour, you're going to get very high spectrum width out of that. So we can use that to find tornadic dust debris clouds. It's very good for that. You'll see kind of like a bubble of high spectrum width where that's occurring. Now, as far as today, we don't have anything like that, but you can see a little bit of heightened spectrum width out here, kind of outlining the outflow boundary. But one thing I really like to use is the change in the spectrum width patterns, the textures. We zoom that out. You can see it's a lot different up north in the Fort Worth area than it is down to the south, where we have the inflow, just the regular moist air coming from the Gulf. That change in texture can help you find that outflow boundary. So if it's not showing up very well on the low-level scans, you can switch to spectrum width and pull that up. So there we go right there. So there's that outflow boundary there at 48 after. Got 5 viewers. I did not expect that so quickly. Because, like I said, this was completely unannounced, and I'm kind of just breaking in all these tools because when we have a really big tornado day like the big Arlington tornado or something like that, hopefully we don't have anything happen like that this year, but if it does, I want to be kind of prepared and do some more of these live radar presentations here, kind of giving you an idea what's going on and look at the storms in detail. So I got this big storm here near Louisville, and one thing I'm trying to do is I'm trying to get the storm relative velocity configured so we can really start using this tool. And I can't really figure out exactly where Mike Gibson put this in, GR2 analyst. Like I said earlier, I normally use GR level 2, and it's in a slightly different location. So I'm going to check through real quick right here. I'll give my voice a little bit of a break while I look through this. Oh, we got a new scan here. Still hanging on to this little bear's cage right here. This is kind of corresponds to the inflow into the storm. Of course, I'll draw that in maybe green. So there's the outflow boundary. So this is kind of like a notch where we're getting the stronger inflow, very strong wind velocity. Maybe seeing a good 20 to 30 knots right there from the southeast along Interstate 35. So that's fuel feeding into the storm here. We'll go up to a little higher level. Okay. As we go higher, we're looking at slightly older imagery. Now, one thing you're probably wondering is where the biggest threats are. I haven't really discussed that in too much detail yet, but mostly the main threat we're looking at from this is going to be hail. There's the hail algorithm picking up 1.6-inch hail. Most of that is going to be concentrated where you see the higher reflectivity values. We're picking up values up to about 65 to 70 dBZs. So that's going to be concentrated pretty much where you see the purple, and most likely the path of that is going to continue eastward along the Highway 190 area, the George Bush Turnpike, into possibly Plano a little bit later, maybe in about 30 minutes. Now, as far as the likelihood of a tornado, I'm not too sure about that yet. We're going to know a little bit more about that when I get the storm relative velocity all configured. In fact, I need to take a minute to go ahead and do that. I'm going to go over to YouTube real quick, and there's a possibility somebody might have left a comment about where that is. And let me see. Okay, yeah, there's nothing in the messages about that. Storm motion vector, no, I don't think that, yeah, I think that's probably going to be where it's going to pull that data. So I'm going to put in 240 at 25 and see how that goes. I think that probably took it. Let me change that just a little bit more and see if it changes, and that way I'll know for sure. Yeah, okay. That's what did it right there. To change that storm motion vector, it's going to be under the toolbar, under, yeah, that, okay. It's going to be right under here. So GR2 Analyst, it's going to be that little button right there that sets the storm motion vector. And you can just kind of ballpark it, and a lot of times I'll change this if I'm not really able to pick out where a meso is, and I'll kind of adjust that and play around with it and try to get it close. So here I'm going for 240. This is from the west-southwest at 25, and what this is telling me right now, okay, so here's our storm. And it's not showing a very strong, tightly packed meso. It's just kind of showing broad rotation. And how do I know that? Well, the radar is down to the south, or the southwest. It's down in southern Tarrant County. And what it's showing is, you see the red here, that's going to be your outbound velocity. And the blue that we have is inbound. So it's showing kind of a general rotation. Not very strong, really. And it's hard to even find a center of rotation. I'd probably say that's going to be right here. What's that highway right there? I'm not too familiar with the roads right there in that part of that area south of Louisville, but it's going to be, this is probably where that weak meso is going to be. Now, what we also want to do is look aloft, because a lot of times the mesos will be stronger as you go aloft. See how that picks up right there? It's a little more strongly defined. And we're up at about 4,900 feet. It's kind of off the bottom part of the screen. But you see the screen right here? In fact, let me change this so you can see the display at the bottom. Okay. And you want to watch the bottom part of the screen right here, because this is the readout of the cursor. So right here where this red is, we're showing 40... is that correct? Yeah. It's actually right here. So we're showing 19 knots outbound because it's positive. So outbound, I mean that we're showing a component of motion. The wind's moving southwest to northwest. And you can see it switches over to minus 66. Now what happened there? Any ideas? What's happened is we're seeing aliased velocity data here. So it's basically the velocities in this area have exceeded the speed limit for this particular volume coverage pattern. So the way we fix that is we have to go into the we have to figure out where in GR level 2 the de-aliasing is, and that's going to be right up here at the top. See, at de-alias velocity. That'll knock that out. It doesn't always work, but let's see here. So now it's showing 21 knots. That's not really very strong at all. So if you're in the southwest part of Denton County, Addison, I really don't think you have to be too concerned right now. Of course, you want to keep monitoring this, but I think you can kind of breathe easy for a bit there. So we've got a meso located right there that's going to be about 5 miles southeast of Louisville. And that's going to be moving toward the southwest Plano area over the next 15 minutes. And we also want to look at higher tilts here. You can see we're picking up kind of a couplet here. See it right there? That's indicative of maybe a meso located right there. The diameter of the meso is also very important, and to measure that, what I'll do is I'll set a marker, then look at the bottom part of the screen right there, and I'll go to the other side of that couplet, and I'm seeing about 3 miles. So 3 miles is definitely in the range of what we would expect for a meso. When we have a tornado in the storm, that's going to shrink down to maybe, we're going to see couplets on the scale of maybe 1.5 miles to 1 mile or less. So we'll go to higher levels, and we're seeing just kind of more of the same here. We've got we've got 31 knots inbound, 27 knots outbound. So this is kind of maybe like a 50 knot meso, not particularly strong. I'm going to set the marker in the middle of that meso, and you can take a look at what it looks like on the reflectivity. And that kind of gives some shape to the storm too. So you see that gives that kind of that S shape that you see right here. And then we can look at the VIL. And you can see the highest. This kind of corresponds to your highest hail threat area, and that's going to be a little bit to the north of that meso. So most of that is going to be concentrated up around the I don't know if it's quite up to Frisco, but yeah, southwest part of Plano right there. And we're going to see that kind of move out into this area of West Plano over the next 15 to 20 minutes. Okay, I'll zoom that out just a little bit here. Now as we go into higher parts of the storm, see we're here at about 17,000 feet. We'll bring this out to 55,000, or I'm sorry, 27,000 feet. And I'm going to switch this over to base velocity. You can see that we're seeing a lot of outbound here, showing 83 knots of outbound. That's the storm anvil kind of ventilating. Part of the anvil goes directly downstream, and a little bit might give us a little bit of back shear on the backside of the storm. Might see that better in the storm relative velocity right there. That's going to be this area. That's going to be a little bit of the back shear on the back part of the storm. So the difference there between the strong outbound and the weaker inbound, that kind of shows us kind of where the updraft area is. So there's a storm right there, and we're getting way up there. Topping out there at about 41,000 feet on that storm. So let's go back down to the surface there. And I'm going to animate this real quick. I'm not sure if that's going to show up very well. Let me slow that down because we're probably going to see some... That's probably going to kind of overwhelm the encoding. So I'll go to animation settings, and I'll slow that down a little bit. So we're seeing it move earlier through the north part of Fort Worth, where we had that tornado warning earlier. And it moves almost directly east, maybe a little bit to the north there. And that's about where we're at right now. So it's tracking on a heading of about 080. Looking at probably about 20 to 30 knots of motion right there. Okay, what's going on elsewhere? Well, let's follow the outflow boundary down. Stuff around Fort Worth, moving into DFW airport area, is a lot weaker. So it's very outflow dominant, and the reflectivities are not very high there either. So this is just kind of a mess of rain. Not doing much more than slowing down traffic. And now you can see we're getting a little bit of an S shape to that outflow. That tells us we're probably seeing a little bit of acceleration of inflow into this area. That's probably been pulled up by this storm here in the Benbrook area. So we'll keep an eye on that. I don't know if it's going to really organize any more than it is already, but that's going to track out towards the Arlington area. Then moving on down, you can see that the outflow kind of disappears. So why is that? Well, we're getting up to about 3,000 feet above the ground. The outflow is not very deep at all. It's probably just a couple thousand feet. So as we get further from the radar, we're getting higher and higher from the ground, and because of that, we overshoot the outflow. So we have to kind of guess where that is, and we don't have any real clues what that looks like down to the south. So here we have to go more by other indicators of storm structure to see if it's getting good inflow or not. This stuff looks very linear right now. You can switch over to the VIL right there to see what that looks like, and we're not seeing much of anything. Just kind of the storms are really fighting the cap there, and there's probably been a little bit of moisture erosion. I'm going to switch over briefly to the surface map and see if we can figure out why that might be. I'm going to pull up the surface plots real quick for the past hour. 10 o'clock there. I'm going to go to data retrieval. This is a digital atmosphere. I'm going to pull up the 10 o'clock data, and we want to get a good idea of what kind of environment these storms are feeding off of. The surface map is a little bit cluttered. Let me fix that a little bit. And I'm going to zoom that in real quick. So here we're zoomed in on North Texas, and I'll put in the highways for you real quick. And we'll look at the 10 p.m. data. Can bring that crowding up just a little bit. Bring it down a little bit. I guess that'll work. We'll quit playing that with it. So here's the front. I guess that's the front. I haven't kept too close tabs there on the surface data, but the main thing we're looking at here is the dew points. See that 62, 61. What we're kind of concerned with here is where the deepest, richest moisture is. And what I like to do here is maybe draw a few key isodrosotherms like 64. We got a little bit of 64 there off the bottom part, and then we pick it up around Palestine up to Tyler. Actually, that goes back further south. And then we'll draw a quick 62. And then I'll draw 60 real quick. This is just a really fast sketch. Okay. So I don't see much of a very strong Tonga moisture coming north. In fact, I see kind of like weaker values down to the south, 62. So there's not a really good fetch of moisture to really crank these storms up. And then the other thing that I'll look at is the surface winds. You can see we've got 20 knots right there on all of these flags. 20 there at Waco, 20 at Hillsborough, 20 at Corsicana. So the strongest feed of moisture is kind of focused in that area. So that would be focused on Fort Worth, and a little bit less feeding the Dallas area. So we'll probably see a slow trend of these storms kind of like weakening, I think, as the evening goes on. What I would want to do is also look at the model data, maybe some of the high resolution rapid refresh, and see if anything is backing the winds, because that can really intensify things. Like if we had like a mesolow developing south of the metro, that might intensify things in the Dallas area. So those are things that I would look for there. Back to the radar. All right, what do we got here? Benbrook storm. Look at those vills. They really picked up a bit there, so that's going to be our next thing to keep an eye on. In fact, a little more intense than the Dallas stuff right there. See that? So there's our Dallas storm right there. So the Dallas storm has backed off a little bit on that notch that we saw earlier. The outflow boundary is still kind of close to the updraft area, so threat isn't completely over. Storm relative velocity there. Looks just slightly more intense, not by very much, right there around the Hebron area. I'll go up into the higher parts of the storm to kind of check that out. Getting a little bit of a high inbound there. That could just be, I don't know how consistent that is with the rest of the data, but might be a very localized bit of outflow. But overall, I'm not seeing a very strong meso or anything like that there at this time. Okay, then what do we got going on in the Fort Worth area? Well, the outflow is still well to the south. So, the storm is really trying to hang in there, but it's kind of separated a bit from the better moisture. That doesn't mean that the storm is not getting inflow, because just above the surface you often see inflow kind of like overriding the surface outflow. So the storm still has access to moisture, but it's not as deep of a layer. So the storm is getting pretty close to the radar, so I'm checking some of the higher tilts there. And I'm not seeing any structures there to be concerned about. Looks like a typical multi-cell right there. So this is going to probably continue moving eastward, kind of like that, maybe along the Interstate 20 area. And whether it's going to intensify is going to depend on whether it can link up with this outflow boundary here. The outflow boundary may continue staying still, or it may start pulling up into the storm, and in that case things might change a little bit. What has the trend been on the outflow boundary? Well, I can back this up a little bit, and this shows us that the outflow has been continuing to surge southeastward. That could always change. That's what we'll watch over the next 15 to 30 minutes here. Then the stuff down to the south, not looking all that impressive there. Got another storm there down near San Saba, but this is oftentimes what we see with a cap. We see the stronger storms up in Oklahoma, and then the stuff down south of I-20 doesn't fire, with DFW right there on the edge. That tends to happen a lot this time of year. So I'll zoom that in real quick. And I'll take a quick break here for just a minute and get some water. So my intention is that when we get stronger severe weather events, I'll try to fire this up, and we'll take a look at stuff as it happens, and that should be very educational. Hopefully we're not looking at anything like the Arlington tornado or the Rowlett tornado that we had last year, but if it does, we'll be able to track it and kind of see what happens. There were a lot of interesting indicators that we saw in that Rowlett storm that you couldn't really tell from listening to the warnings what was going on, but you could definitely see it on the radar. There were some patterns like the very strong convergence, strong storm relative convergence that we see just before tornado genesis. We would have been able to pick that out, and that's usually one of the indicators that I look for right before that happens. It was really interesting seeing that Meso come together. You can definitely tell that things were going to get bad there. So things looking better here with this Plano storm. You can see it has more of a linear structure here. You can see this hail indication. It picks up. It's suggesting 2 inches of hail. That's not observed. That's kind of calculated by the radar. And that's based on a bunch of different factors like the intensities, the radar intensities above a certain level, where the freezing level is, and so on. And what we see on the ground is not always what the algorithm gives us. So things are looking a bit better here in the Plano area. But the VILs do seem to be picking up a little bit. Let's see what the trend on the VIL values have been. I'm going to back this up. They were definitely weaker about 10 minutes ago. Kind of looks ambiguous what the trend on that is. It's definitely continuing to hold together, but like I said, it's kind of linear right now. And what does it look like aloft? Kind of the same thing. And then the other thing that we look at is the Meso, and what do we have for a Meso here? Remember, to really see the Meso, we have to go up to the mid-levels of the storm. So now we're up at about 11,000 feet, and we're seeing mostly, now we're seeing a little bit of inflow there, or not inflow, but inbound into where the radar is. That's in the precip area of the storm. Don't see much in the way of inflow, like outbound velocities. Okay, that's getting up a little bit too high. Let me bring this back down to the low levels. So, looking pretty good there for the Plano area. Just a lot of wind and heavy rain and maybe a little bit of pea-sized hail, maybe some marble-sized hail mixed in. Then what do we got for the Fort Worth area? Well, this thing is looking still pretty good. I think it's pretty safe to say that just above the surface it's almost certainly getting a bit of inflow, because we can see a little bit of a notch-shaped appearance on the leading edge of the storm. So what do the VIL values look like? Well, this doesn't give us a complete picture, because the problem is that the storm is so close to the radar that it's getting a little bit hard to sample. For example, I'm going to go up to the very highest tilt. 19.5, you cannot tilt the radar any higher than 19.5, otherwise you break it and it falls off the pedestal and then you have a big disaster. But this highest tilt, this is up at let's see, 11,000 feet. The storm extends up to 40,000 feet, so we can't sample the whole thing. The highest tilt kind of just cuts into the mid-level part of the storm. So what that means is the echo tilt, or I'm sorry, the echo tops products are not valid. See, it's not picking up a maximum tilt on that storm. And that also affects the VIL values. You can't really get a good, you can't really compare this very well to what you have out in Plano. All right, let's see here. When we do these radar things during severe weather, I'm going to look more at the ZDR, the correlation coefficient, and so on, and we'll go into detail on what those mean. KDP is one that we can look at a little bit. This is kind of like a proxy for, well, I'm probably not going to get into too much detail on that, especially since ZDR is not showing a whole lot, and correlation coefficient not showing anything important there either. It's just showing high velocities, which mean rain. All right. So I'm not going to really worry about the polarimetric products too much right now. Storm is getting very close to the radar there, so you can see what we have up at. See, look at that. We're up at 19.5 degrees. We can only scan up to about 8,000 feet on the storm. That's still good enough to find mesos, but we can't scan the upper parts of the storm. So now we're just about completely up on the radar. What we do if we really have to have access to those higher level tilts is we will switch over to a different radar. For example, Dias or Fort Hood, their radar. In this case, we don't have to worry about that too much. The storm is going to pass over the radar, and then it's going to be back on the east side, and then we'll be able to check out those higher tilts again. Now, as far as severe weather indicators, what do we have? What we're going to be looking at is mostly reflectivity gradient. Reflectivity gradients are really not too high along the leading edge of the storm. So, as far as severe weather signatures, I'm not seeing anything particularly bad. If I was living out maybe in this part of Tarrant County out ahead of it, I don't think I would be too concerned, especially with the outflow boundary near the surface being pretty far away from the main storm. So I took a look at spectrum width to kind of see if that is consistent with the reflectivity data. And this suggests to me that maybe a little bit of the outflow is starting to sneak north of the outflow boundary, because the textures that I'm seeing in the Midlothian Mansfield area look to be about the same all the way up to the radar site itself. See, 0.9, this is going to be just above the ground, 1.3, 1.8, yeah. Now we're getting into the higher tilts. So it appears that storm is sneaking a little bit of inflow. That's probably what it's feeding off of, a little bit of that moisture maybe creeping northward above the old lower, shallower outflow boundary at the surface. So probably seeing a little bit of that sneaking north like that. Now you see there's a little bit of change in the character. See that? Now we're seeing a little bit of a notch. So yeah, see, this would have me a little bit concerned. That kind of ties into what I just showed you there about the storm, the spectrum width. It appears it's starting to pull in a little bit of inflow right there. Now, as far as what I want to do now is look at the storm relative velocity. Not showing really much of a meso there. This is not really an ideal setting. What I'm going to want to do is change this so I can kind of get some detail out of this and see some inflow, because what it's showing right now is mostly inbounds into the radar, and it looks like I need to decrease the storm motion just a little bit maybe. So let me do that real quick. 15, yeah, that helps a little bit. 260. Yeah, that probably gives me a little bit more of a balanced picture. The velocities are on the order of 10 to 20 knots inbound, not really any outbound, so we're not looking at a very not looking at anything that concerns me too much as far as the velocity signatures there. Of course, I want to look up at the mid-levels of the storm to see if there's maybe a mid-level meso. The problem is it's still very close to the radar, so it's kind of hard to tell these details, but I can see there we got 22 knots outbound. So that probably suggests maybe kind of a weak meso right here, centered right there in that Everman area. Storm is already pushing past that. I'm not even sure if that is a meso, to tell you the truth. The velocity field is just so weak, it's kind of hard to pick out those details there. However, the storm there is, it's still showing that little notch there, but that's the only feature of concern that I see right now. And I should reiterate that this is kind of on the weak side, and there is a severe thunderstorm warning for it, but that's mostly, I would say, just to kind of cover themselves in case something does happen. And there certainly is the potential for it to, intensify a bit, but again, those features that I discussed, those techniques, they kind of paint to maybe the storm being on the marginal side. Very linear appearance there on the Plano storm, so not much of a change there. So the main thing I would be concerned about there is maybe wind, because we're seeing a little bit of this bowing appearance, so probably getting a little bit of wind through there. Maybe Plano to Murphy area is what I'll be watching right there. So if I was looking at the potential for wind, I would probably place it in this box right there. Alright, so going down the line, mostly just a bunch of multi-cells all the way down through Granbury, all the way to Stephenville, all the way down to Dublin, and we've got some new development there southeast of Brownwood, and we just go on down the line. It looks like this stuff is starting to pick up a little bit as it approaches the deeper moisture. That's mostly in an area with dew points around 60, but the deeper moisture is just to the east, so that'll probably start firming up into a line and then move towards the I-35 area later this evening. So not a whole lot going on right there. So I think we're looking pretty good there for the Dallas-Fort Worth area. Had that one tornado warning earlier there in the north part of Fort Worth, but other than that, looks like the Metroplex is kind of locked out for tonight. Anyway, that's about all I wanted to cover. Again, mostly this was just kind of an experiment because I'm going to be doing these videos as we get into severe weather season, especially for storms around the Dallas-Fort Worth area and maybe Oklahoma City. And tonight was mostly to kind of work out the bugs and get everything working, and especially on the encoding and YouTube side. I'm using this broadcaster software here, and we're kind of on a slow internet connection, so I don't know how well the encoding software is working or how well the uploads are doing, but hopefully it was okay and you didn't see any really bad encoding artifacts there. So I think that'll probably do it for tonight, and maybe check back here and watch the page, and we'll see how we'll do this again next time, and we'll probably have some more stuff to look at. Anyway, thank you for watching, and I appreciate it. See you next time.